Grace and peace to you, and welcome back to my channel. This is Donald Siame, author of Hidden Mathematical Genius Within Reviewed. We continue on our algebraic fractions. So we have the first question there. Simplify 9a minus c over 81a squared minus c squared. Okay, so I said if you want to simplify algebraic fractions, make sure that you factorize both the numerator and the denominator if they are factorizable. Okay, so we start with the numerator. Is 9a minus c factorizable? No, because we cannot apply common factor, we cannot apply difference of two squares, and we cannot apply factorization by common factors, even searching method. So the numerator will be as it is. Okay, so we have 9a minus c over, then the denominator we have 81a squared minus c squared. Is that factorizable? Yes. We can see that 81a squared is a perfect square. There is a square root for 81 and there is a square root for a squared. And c squared is also a perfect square, and there is a minus in between. So this can be factorized by difference of two squares. So you say the square root of 81a squared is 9a. So we are going to have 9a plus the square root of c squared is c. So 9a plus c. Then you repeat the same thing, but with a minus in between. So 9a minus minus c. So it's the product of 9a plus c and 9a minus c. Now, if you look at the numerator and our new denominator, we can say that there is a common factor. There is 9a minus c in the numerator, and there is also 9a minus c in the denominator. So we'll say 9a minus c in 9a minus c, it will be 1. So there we have 1, and there 1. Okay, so on the numerator we have 1 and over, on the denominator we remain with just 9a plus c and 9a plus c. So we have 1 over 9a plus c. So we have simplified. So 9a minus c over 81a squared minus c squared is simplified as 1 over 9a plus c. Okay, so that was the first one. Then the second one we have 2x minus 14 over 2x squared minus 98. Okay, so if you start with the numerator, is the numerator factorizable? Yes, the numerator is factorizable by common factor. We can see that there is a common factor there of 2. So we are going to divide out 2. Okay, so we have 2. So when we divide out 2, 2x divided by 2, remain with x. Then minus 14 divided by 2, you get 7 over, in the denominator we have 2x squared minus 98. Again, we can see there that 2 is common, so we need to divide out a 2. Okay, so we have 2, 2x squared divided by 2, we have x squared minus 98 divided by 2, you get 49. Okay, so we can see on the numerator we have 2, the product of 2 and x minus 7, and then on the denominator we have the product of 2 and x squared minus 49. Okay, 2 and 2 can cancel out. So 2 there is 1 and 2 there is 1. So we are going to have x minus 7 over x squared minus 49. Okay, again if you look at the denominator can be factorized again. Now can be factorized by, we use a difference of 2 squares. We can say that there is a minus in between, and the two terms are perfect squares, because there is a square root of x squared and there is also the square root of 49. Okay, so the numerator will be maintained, that is x minus 7 over, what's the square root of x squared? X. And plus, what's the square root of 49? 7. So you repeat the same thing, but with a minus in between. We have x minus 7. Okay, again if you look at the numerator and the denominator, we can see that there is a common factor of x minus 7. So x minus 7 in x minus 7, it's 1. X minus 7 in x minus 7 is what? 1. So on the numerator we have 1 over, then on the denominator we have x plus 7. Okay, so 2x minus 14 over 2x squared minus 98 is simplified as 1 over 7. Thank you so much for your time.